Hi there, Agentic Machine Learning. It's a very interesting topic and I'm going to explain you all about it. But first we'll start with the very basics, like what is an AI agent? And then we'll go into why AI agents are useful for machine learning. I'll show you two agentic architectures for machine learning, a single agent architecture and a multi-agent architecture. I'll be also showing you a very exciting demo, and then we are also going to go into a conclusion and key takeaways. But first of all, let us start with the fact that what is an AI agent. So an agent is a way in which you can automate some manual task. And an agent has got three components. First is a large language model, which is doing the reasoning, which is planning, which is deciding what steps to take. So this you can compare it with a brain. The second is the tools where all the actions are taking place. So tools are ones which are going to call APIs, they are going to run code as well as they are going to retrieve the data. So this you can think of it as hands. And the third is the system prompt, which is the behavior of how an agent is going to work. So agent is basically three things: large language models plus tools plus prompts. Now let us see on why agentic AI is useful for machine learning. Now, as data scientists, machine learning experts, we all know that there is a lot of manual steps, manual decisions which we have to take. For example, you have to decide on what techniques to use for data preparation. Or for example, you have to decide manually on the features which are useful for the model. And sometimes you also bring in some experts who are going to handpick the features. And then you also have to decide on what model, what algorithm to select. Now, AI agents can help you to automate all these decisions by taking these decisions by themselves. So they can profile the data automatically, then they can also decide what is the best data preparation approach, as well as they can also decide what is the algorithm to use. So agentic machine learning can help you accelerate your machine learning process. You do not have to write the machine learning code by yourself, but the agent is going to do it for you. Now let us go into the different architectures which are available for machine learning with AI agents. So this is a single agent architecture, and here we can see these three components which I talked about earlier. So let's say you have a large language model, which is in this case a Claude HiQ model, which is the brain of the agent, and then it is going to work with tools. So tools, you need different tools, and the four tools which I have listed here, like data profiling, data preparation, model training and model evaluation, are the tools which help the agent to do machine learning. And you also need to define a system prompt which will say that you are a machine learning agent and you are going to use various tools in order to do the machine learning. And then you also have to give a user prompt to this agent such that you give the data set and then you can say make a machine learning model to do some prediction. So once you give that, this agent is going to leverage all the tools and then it is going to make this machine learning model. Now, a second architecture is a multi-agent architecture. So instead of one agent with all the tools, you can have different agents for different machine learning tasks. So you need a supervisor agent which is going to coordinate across all the different agents. So this supervisor agent is going to take the user task and then it is going to pass it to the data profiler agent. The data profiler agent is then going to pass the work to the data preparation agent, which is then going to pass the work to the model training and then to the model evaluation. Now, you also need a shared state where all these agents can exchange information amongst them. And the advantage of this approach is that you can specify an objective. So you can say that I would like to have an accuracy more than 80%. So all these agents are going to work collaboratively with each other in order to achieve that accuracy. Now let me show you on how this multi-agent architecture would work in action. So this particular architecture, I've built it using my platform called as datajarvis.ai, and you can also try it out. But first, let us see the data on which we are going to work with. So this data is coming from telecommunication customer data set, which has got information related to the customer, as well as it has also got information related whether this customer has left or not, whether this customer has churned or not. So this model we are going to, or this agent we are going to use to predict if a customer is going to leave or not. So we can start the agent and we can ask the first question, such as, for the data set telco underscore customers, make a machine learning model to predict the target variable, which is the churn, and we can also specify that we would like to have an accuracy more than 80%. So once we launch this agent, the agent is going to first of all take all this information and then it is going to update it in the shared state. And then it is also going to give you all the information which it has gathered from the prompt, and it has identified that what are the different agents it is going to call, like data profiling agent, machine learning agent, as well as the performance evaluation agent. And then it is going to pass the work to the data profiling agent, and here you can see that the data profiling agent has completed its task, and it will also update the information back to the shared state. So here you can see that the data profiling agent is complete, and it has identified some fields which have got very high cardinality, which means that it is a candidate for dropping it. Plus it has also identified that the data set is imbalanced. And now it is going ahead and passing the work to the data preparation agent. And here you can see that the data preparation agent is called, and it is also going to update the shared state. And here you can see that it has completed the data preparation. And you can see that it has also created a new data set based on data preparation. It has also listed all the different cleaning actions which it has taken, as well as it has also listed the different features which it has retained for making the model. Now it is going to pass the work to the model training agent, and let us see what the model training agent is going to do. As you can see that it is going to first of all use the random forest algorithm, and you can see that the accuracy is 78%, which is not as per the target. So it is going to come out with this conclusion that yes, I've used random forest, but the accuracy is below the target, and it has also given the different features which it has found which can predict the target. And it has also done this analysis, and next step it is taking that now let me use another powerful model, which is the gradient boosting model, because the accuracy is not as per target. So you can see that it is acting based on the objectives what we have given to the agent. So now you can see that the agent has again trained a machine learning model, but this time with gradient boosting, and you can see that the accuracy is above 80%, which is great. And here you can see that it has come out with a conclusion that it has completed the machine learning task and the target has been achieved. So you can see that the target is achieved. It has also identified the top features which are contributing to the churn, and it has also given some key insights which business can take, as well as it has also created a machine learning pipeline summary, as well as the recommendation on actions to take. In addition, it has also created this final evaluation report using gradient boosting. It has given the confusion metrics, as well as it has also given the top feature importance. So this is really powerful. As you can see that the agent has completed all the tasks, it has used all the sub-agents, and it has come out with an accuracy which is as per, and it is more than what we have specified. So you can see the power of multi-agent architecture. All the decisions which are usually taken by human in a machine learning process have been taken by agents, and we just need to give a prompt and the data set, and agent is going to figure out automatically on what steps to use and how to improve the model. Now let us see the key takeaways. So first of all, agentic machine learning is the future. So you need to really concentrate on this particular topic, and I would also recommend that you should stop manually building the machine learning model, but instead you should build agents which are going to do the machine learning for you. So hopefully you have enjoyed this video. You can try out this agent building on my platform datajarvis.ai. So please subscribe to the channel, please like the video, and in the next videos, I will also show you exactly on how to build that multi-agent architecture. Thank you for watching. Bye.